Alright, so now we're going to go to an example that has, as I was talking about before back in the last video, a function that has a hole in the graph. If you look at this function here, g of x equaling x squared minus 4 over x minus 2, you would see that of course x cannot equal 2, but that this would factor and simplify to x plus 2. So y equals x plus 2, well, that's a line. This is going to be kind of a so-so graph here. This is a line that has slope 1 and has y-intercept at 0, 2. This is why I use graph paper. So if I was to graph the line that had slope 1 and y-intercept here at 0, 2, slope 1 would mean up 1 to the right 1, I would get a line that looks like this. In fact, not drawn very well. But when x equals 2, x cannot equal 2 as it turns out, because it gives me 0 in the numerator and the denominator. I have a hole in my graph. So I have a line with a hole in it. So you have to be on the lookout for that when you're finding vertical asymptotes. This one does not have vertical asymptote. It has a hole in the graph. Now, in the last example that we did from the previous video, I had a graph that involved, I think it was f of x equals 1 over x minus 2, that involved both a vertical and a horizontal asymptote. Now, we defined the vertical asymptote based on what happens as x approaches some value where it's undefined, such as in this case at x equals 2. But in a horizontal asymptote, it's approached a little bit differently. First off, it's horizontal line, so that means that it's going to be a y equals a number. I use y equals d here to match up with the textbook. The line y equals d is a horizontal asymptote of the graph of the function f if f of x approaches d as x goes to infinity or as x goes to negative infinity. So that's a little bit different, but the good news is that there's kind of a way that we can look at the equation based on lead coefficients and degrees of the numerator and the denominator to help us to find these horizontal asymptotes. Because this is kind of like end behavior. What's going on here? What's happening in my graph as x gets really, really big or really, really small? Now, I mentioned also in one of the other videos, I think it was the last video, that a graph of a rational function will not cross a vertical asymptote, but it may cross a horizontal asymptote. So I'm going to reinforce that just a little bit. Let f be a rational function defined by f of x equaling x sub n, a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, and so on, plus dot 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 a sub 1, x to the first, plus a sub 0, all over b sub m, x to the n, plus b sub n minus 1, x to the n minus 1, and so on down to b sub 0. Now, notice here that my degrees are different. The numerator has degree n, the denominator has degree m. Now, based on what the degrees are, for example, if the degree of the numerator, n, is greater than the degree of the denominator, then there are no horizontal asymptotes. I'm going to put a little star next to this because if the degree of the numerator is 1 greater than the degree of the denominator, we have what we call an oblique or a slant asymptote, which I'm going to get to in just a little while. Now, if the degree of the numerator is smaller than the degree of the denominator, then the x-axis, y equals 0, is always the horizontal asymptote. And if the degrees are the same, if x or n is equal to m, if they have equal degree in the numerator and the denominator of this rational expression, then what we do is we take the ratio of the lead coefficients, a sub n over b sub m, and that y equals that ratio of values there, those would be two numbers, so this is going to be a constant, y equals this number is going to be the horizontal asymptote. Now, before we get to doing any real graphing, because we are going to graph rationals, we want to be able to identify and find the horizontal asymptotes, and I have 3 examples right here. Notice in this first example, the degree of the numerator is 2, the degree of the denominator is 2. They have equal degree. So that's this third case. So I look at the lead coefficients, which would be 7 and 4 in the numerator and denominator respectively. So my horizontal asymptote is y equals 7/4. On this example, the degree of the numerator is greater than the degree of the denominator. In fact, it's 2 bigger than the degree of the denominator. That means we have no horizontal asymptote. I'm just going to abbreviate HA for horizontal asymptote. In this last example here, the degree of the numerator is 0, the degree of the denominator is 2, so the degree of the numerator is smaller, case 2 is smaller, and so that means that the horizontal asymptote here is y equals 0, which of course is your x-axis. Alright, so that's pretty easy. You're looking at the degrees, and in some cases, if the degrees are the same, you're looking at the lead coefficients. Now here's an example, and notice here that this particular function, g of x equals 3x squared plus 4x minus 3 over x squared plus 3, has equal degree top and bottom. I want to determine the horizontal asymptote, and as I mentioned, your graph may cross your horizontal asymptote. I want to find that point where the graph crosses the horizontal asymptote. So in this case, if I look at the degrees, they're the same. The lead coefficient of the numerator is 3, the lead coefficient of the denominator is 1. So my horizontal asymptote is y equals 3 over 1, or y equals 3. Here, I just probably would write y equals 3. Okay. Now, if I want to know where my graph crosses the y-axis, what I want is, when is my y value equal to 3? So I'm going to take the rational function here of 3x squared plus 4x minus 3, and I'm going to put it all over x squared plus 3, and I'm going to set it equal to 3. In fact, I'm going to set it equal to 3 over 1, and then I'm going to cross multiply, so I'm going to solve for x. So this is 3 times 3x squared plus 4x minus 3 is equal to 1 times x squared plus 3, excuse me. So this is 9x squared plus 12x minus 9 is equal to x squared plus 3. Oh, I did it exactly backwards. So let's try that all over again. This time let's do it correctly. Alright, so I'm going to cross multiply, so it's 3 times x squared plus 3, and it's 1 times 3x squared plus 4x minus 3. Would be nice if I paid attention. 3 times x squared is 3x squared, distributing, plus 9 equals, looks like 3x squared plus 4x minus 3. I have a 3x squared on both sides, so if I subtract 3x squared from both sides, I get 9 equals 4x minus 3. Add 3 to both sides, I get 12 equals 4x. Divide by 4, I have x equals 3. So when x is 3, and you plug it in, it gives you a y value of 3. So at the point, where does it cross? It crosses at the point 3, 3. Crosses the horizontal asymptote at 3, 3.